We're asked to evaluate this indefinite integral. So to figure it out, you could try to sit there and imagine what the function would be. Maybe you want to put x squared inside, that way the chain rule gets you an x to the first power, but that doesn't quite work out. So when the functions start getting complicated, you'll have u substitution as a tool. You could try to let u be x, then du would be 1, but that doesn't make it simpler. Or you could try something called integration by parts, which is like where you make a double substitution. You pick a u for your function, and then you pick a dv for your function. And then you can write the integral as uv, there's no integral operator there, minus the integral of v du. And you might be thinking, well, I still have an integral. How does that help me? It's you're going to try to pick a u and a v to make the integral simpler over here. Okay, so the trick to it is you want to start by picking a u and picking a dv to make a substitution. And it is a little bit of guesswork, but the strategy behind picking u is you want to pick something so that when you take a derivative, it gets closer and closer to turning it into nothing. So for this, if I was to pick u to be cosine of x, then when I take a derivative, du would be negative sine x, and then if we were to take another derivative, that'd be negative cosine of x. Sine and cosine are they make a cycle when you're trying to find derivatives. So that's not what I want to pick for my u. I know that if I take a derivative of x, it's 1, so that gets much simpler. So I'm going to pick u to be x, and then dv will be the other part because we have to wrap up the entire integral with both of these things. Okay, so that's how you start these problems. You pick a u and you pick a dv, and it might be just a little bit of guesswork when you first start. Okay, now once you pick these, you've got to calculate your du. So take a derivative with respect to x, that's just 1. And then you've got to calculate v. Now if this is the derivative of v, then v would be the antiderivative of this. So you need to think of something whose derivative would be cosine of x, and that's sine of x. Right? The derivative of sine is cosine. So this is our v, and this is our dv. But remember, when you do integration by parts, you start by breaking this up into these substitutions. Okay, so now that we have it, now we can plug it into the integration by parts formula. The formula says that your integral is going to be equal to u times v, so it's x sine x, minus the indefinite integral of v, which is sine of x, and then du. And du in this case was just 1, so you can put a 1 there or not. But then that's with respect to x still, so we still have to have a dx there. Okay. All right, now that's a much easier integral to handle, right? The indefinite integral of sine of x is negative cosine of x, because the derivative of negative cosine would be sine. So let's evaluate that indefinite integral. We're trying to find the antiderivative of sine of x, and that's negative cosine of x. Just watch your double negative signs. And then don't forget your constant c when you find an antiderivative. When you find an indefinite integral, I should say. And we're done. It's minus the negative cosine of x, but that's just plus cosine of x, right? So you can check me too. You can take a derivative term by term, and you'd see it does turn back into x cosine of x. So that's how you use the integration by parts formula. You pick a u, you pick a dv, and then plug it into this part of the formula and see if it makes things simpler.